Well, good afternoon, everybody, and welcome to Ellensburg, Washington, USA. Oh boy, we're on our last legs. Old mega whale is now in pieces. I don't know. We might use this. Thank you for joining us today. The local time is 1:48 on a glorious, beautiful Wednesday afternoon here in Ellensburg, Washington. And we will begin our program at 2 o'clock. That's about 11 and a half minutes from now. I see 5 by 5. Thank you for being good about that. Let me grab a little hot beverage and say hi to a few of you. Now, you know what? I'm going to email. We got 3 guests. I'm going to email them right now. It's going to take a while to get them sorted. So give me a second. As long as we're 5 by 5 and I see that, thank you. Add the guest, plural. I am pasting a link. And I'm sending to Mitch, Will, and Danny. All in one email, no big deal. That should work. Let's hope it works. Great to see you today. Thank you. Unity, Wisconsin, Tacoma, Washington. Where are you viewing from? Southern Arizona, Hayward, Fulton, California. Andrew is Dawn is in Perth, Australia. Bergen City, Norway. Deering, Kansas, Walla Walla, Washington, Camino Island, Washington, Lacau, Finland, hello Anna, Koskob, Connecticut, Chiclayo, Peru, Yorkshire, UK, Copenhagen, Denmark, Beaverton, Oregon, Sulphur, Oklahoma, Orem, Utah, Fair Oaks, California, Tucson, Arizona, Portland, Oregon, Carlisle, Pennsylvania. Yes, Norley is back. She is in Africa and had her first episode of season 7, I do believe, and I was very surprised that she's tackling Africa now. Very excited about that. So yeah, we're just about to wrap up here, and perfect timing. Norley's just getting rolling with 3 short videos per week. If you're unfamiliar with an excellent YouTube channel, Itchy Boots, starring Norley, a motorcyclist and geologist, and she is a major role model for me and many, many others. Yokohama, Japan. Hello, Naoki. Hello. Scott's deep in the Ozark, Denmark, Iowa. Sorry, Tim. Oh, okay, you're the Tim Miller. I thought maybe it was Tim Miller, the grad student upstairs, but I'll give him a dirty look next time I see him in the hallway, because you're the Tim Miller that's been watching from Iowa. Steiner is in Bergen, Norway, Weatherford, Texas, Fairwood, Washington, Bremerton, Washington, Lake Tahoe, California, Philomath, Oregon. Hello, Kirk. Göteborg, Sweden. That's another Kirk. Renee is in Quebec. Pedro is in Portugal. Hello, Pedro. Yeah, I'm not expecting the extra foreign lands tonight. It should be late there, shouldn't it? Oh, my God. Jerome Lessman is in Engelberg, Switzerland. Jerome, what's up, homie? Jerome and I both have family history in Switzerland, and he's on sabbatical, and I was hoping that he would join us. What did he say, Jerome? Nanaimo via Engelberg, Switzerland. Hey, all right, Jerome. Come on now. Thank you. Thank you. It's late there. Crown House is in Vienna, Austria. Who we got in the green room here? We got Danny. Hello, Danny. Can you hear me? Okay, good. And Mitch, you can hear me okay? Okay, wonderful. Waiting on Will. And if either of you guys want to share your screen now, go ahead. We'll just put that in the green room as well. We got two in the house. We got one more coming. Trevor's in Nanaimo, British Columbia. Hello, Trevor. And everybody's saying hi to Jerome. That's nice. Hans is in. And Waikile, Hawaii. Hello, Adventuresome Barada. Backcountry Gary's in the his. Hey. Hello, Gary. And there's a shared screen from Danny. And now I'm realizing that the green room is going to be full of stuff. I'm not even going to see Will until he shows up. That's fine. I'll just keep an eye out. All right. I have a quick announcement. I've made it briefly before, but I want to do it again right now. I think I'm going to make this announcement twice today and twice on Saturday, which is our last show, of course. So you know that I live here, and this is our view, believe it or not, to the north of town. And we have had sunrises and sunsets lately similar to this. And you should know if you're interested, I am giving 4 live lectures downtown in Ellensburg, and you are invited. I have an auditorium that has 700 seats. And here's what I know so far. I've made the reservation. A friend of mine operates the auditorium. It's called Morgan Auditorium. It's down on First Street. And I'm going 4 nights in a row, 7 p.m. It's free and open to the public. And I'll announce this again at the end of the show today. But I think I have an ask for you. I have an idea, but I don't know if I love it. My idea is I want to give 4 lectures boiling down essentially everything I've learned in the last 3 years involving exotic terrains. And I want the 4 lectures to work together. I don't know quite how to do it. The only thought I have right now is to tie all 4 of them to Mount Stewart. Basically have it be 4 Mount Stewart lectures. And the first one might be Mount Stewart Bathyllus, and the next one is Mount Stewart Lost Oceans or something. Basically, it's an excuse to use a local landmark with the Holy Trinity and then go Alaska to Mexico. But I don't know if that's the way to go. So I'll ask again late today and also on Saturday, but I'm looking for ideas on how I could come up with some sort of way to package those 4 lectures, have them work together, pick a title that is obvious to everybody, even folks who've not been with us and have no idea. They're just coming off the street, basically. I see a crowd walking into the auditorium. They're like, oh, I'll go check this out. So we're workshopping ideas. I still don't see Will. Now, why would that be? I'll wait a couple more minutes, but Danny, I might have you text Will. Make sure you got my email. All right, let's say hi to a few more of you. Assembling Washington. Thank you, Bill. I'll enjoy watching the replay and seeing all of your comments and ideas. Thank you. Where are you viewing from? Let's say hi to a few more folks, and then I have to start thinking about today, although today will be unusual, as you will see. Red Lester's in London, England. Heard of it. Albany, Georgia. That's Stephen. Troy is in Aalborg, Denmark. Carla's in Rogue Valley, Oregon. Brian in Orange County, California. Anthony is in Helena, Montana. Okay, I'm starting to get distracted. I got Danny and Mitch in the green room. I have Danny's shared screen and Mitch's shared screen in the green room. Danny, would you mind texting Will, and I'll email him again. Make sure that link got through. There's a different Will. Will Bradley's here from Albany, Oregon. And Adele is in Auckland. Adele, are you with us? Somebody's replying to you. I think I saw that. Ron is skiing in the Peshastin Syncline. Oh, hey, watch out for that tree, Ron. Keep your eyes up. Looking at your phone as you're skiing. Evelyn is she's listening in the heart of Nevada. I think some people listen to these things. They don't watch. They just listen. That's kind of an interesting concept. Hey, there's Will. Okay, I feel better. Will, I see you. Good. You can hear me. You can go ahead and share your screen too, Will, if you like. You know what? We're good. We're good. Great. We have all three of our guests in the green room, and I have 2 minutes to get, less than that. I have just a moment to get my head right. Thank you, everybody, for joining us today. We've got more than 500 already, and folks will continue to trickle in. Show Y is about to begin. Here's to you. Hot mic. Hot mic. Okay. This is an experiment today. This is a roundtable discussion. You're going to have everybody on camera together. You're going to spend the first 10 minutes setting the stage. You're going to have a question for the Zircon guys. You're going to bring them on first. Bring on Danny first, then Will. Have Danny and Will on together. Ask them for a little bit of detail there. Then we bring in Mitch, and we go where they want to go. Got to make sure to set the hook. Make sure everybody remembers who Mitch is. Make sure everybody remembers the basics. What are you doing? You're doing the basics, boy. You're doing the basics of Nanaimo. You get to it right away. This is not you. You're not teaching a lesson on the Nanaimo, for crying out loud. You've got the experts here. Keep it very quick. Keep it light. Yeah. Laptop, right. You got to show the papers. Show the papers ahead of time, just like you did with Chris last time. Okay, brisk chalkboards, laptop to show the papers, then we go to Danny first. That's the plan. Ready, break. Ready, break. Ready, break. Ready, get set, go. Hello and welcome to Ellensburg, Washington University, home of Central Washington University. I'm so pleased you're with us on this, the last Wednesday of the winter for us. We have one more show. Let's look at the schedule really quickly. If this is session Y, that means there's one more show. And the last installment of the series is Saturday morning at 9 a.m. Pacific time for session Z. Got nothing but Canadians here today, so I have to say that. Nothing but session or show Z, and our guests, our guests will be Basil Tikoff, Karin Siglock, and Stephen Johnston. All three of them together, similar to what we're doing today with Danny, Will, and Mitch. We're going to try to reflect on the series. We're going to try to pull out some themes. We're going to kind of strategize what might be doing, what some people might want to think about doing over the next decade, although that's bonus points for that. Basically, we want to just chat, and that's really the hope. But I think I want to do two things with you before we go to our three guests. I want to remind you who they are. I want to remind you some basics of what we learned before Christmas. Before Christmas, 2 months ago, we were talking about the Nanaimo, and I needed to go back and watch the Danny Coutts show on Nanaimo, zircons, and I needed to go back and watch the Will Matthews Nanaimo Sources episode. I took a bunch of notes. I remembered most of it, but it was just satisfying to get that again. And I want to condense it really quickly here on the chalkboards and also lob out a couple of questions where as I was drawing this stuff out on the chalkboard this morning, I'm like, I don't think I still have this. I thought I had it, but I'm not sure I have it. So a couple specific questions for the zircon fellas. Then we bring in Mitch Mihalynuk, who is part of the research team of Karin Siglock and Mitch Mihalynuk from the fixed archipelago model, the tomotectonics, the ribbon candy scene. And I don't think Mitch has a long history with Danny and Will, but we're going to collaborate and just kind of share expertise and think about British Columbia a lot here this afternoon. Okay, those are my two goals, and then we go to them. So yes, we have these 4 tectonic models, and we're wondering, I guess I'm revisiting the Nanaimo Basin to ask those gory details, those beautiful, rich details we had from the Nanaimo Basin with Will and Danny. Can we rule out, can we support, can we go back and forth? Now that we know these models that are in play, how can we take some of that detail from the zircons and use it or not use it or that sort of thing, okay? So I'm not going to go through this again. This is Warren Hamilton, Bill Dickinson, Basil Tikoff, Bernie Housen, Karin Siglock, Mitch Mihalynuk, who you'll see again in a second, Stephen Johnston, Bob Hildebrand. Okay, it's going away. Bijou, you're going away. Today we go, this can be quick. This is most of the map we had last time. We're not going to the North Cascades, I don't think, today. We're leaving Ellensburg and we're going up to Vancouver, we're going up to Victoria, and we're going to the body of water in the Gulf Islands that are up here where we have confetti. Well, I mean, come on, I got off of confetti pretty quickly because I thought the idea was we had incredible diversity in sand grains within the Nanaimo Basin from 90 to 63, but I realized it wasn't as diverse as I thought, and that's one of the main points that we're going to hammer today. That's going away, done with it. Man, I'm rolling through the chalkboards even faster than I was hoping for. Well, I got something new on the back of this that I'm excited about, and it's the main question that I have. This isn't new. We did this last couple of shows just to get the blood flowing again for everybody. If we like mega whale, and we want a major amount of the Western North American crust moving north between 85 and 55 or between 70 and 50. You know, we've been toying with those ideas over the last few shows. Do we have some sort of major fault, the Tintina or something related to that, allowing everybody moving north, mega whale, insular and intermontane, joined at the hip and moving as a unit? Or do we want to revert back to the whale, not the mega whale, and have a narrower sliver of crust going north at a certain a certain time? So, intermontane, Tintina, paleomag. Let me just toss it out, see if anybody wants to comment on it. I thought our best paleomag, going from, and Chris Mattinson brought this up in the last show, I thought our best paleomag from plutons, from lavas, from sedimentary units generally decreased. We're talking about amounts of translation. I thought our translation distances decreased as we went farther and farther inland. And yet, if we're talking about mega whale, don't we need a carbon copy? Don't we need all those paleomag results to be the same if we're moving the mega whale all the same amount at the same time? Or, as Chris Mattinson, again, just feeding off of his energy and his open-ended questions in the last show, do we want to bust up mega whale into individual pieces and have not only moving north, but rotating clockwise and having, what did Chris say, a school of mini whales or something moving north? Merle Beck had a ball bearing model where each piece of crust was a separate ball bearing that were rotating as they were being translated to the north. We may go there, we may not. We may talk about mega whale, we may not today. But to zero it in for the zircon guys, here's why I was drawing this out at 9 o'clock this morning in the classroom, in between classes. And here's where I kind of caught myself. Slowing down now for dramatic effect. Here's the Nanaimo Basin, potentially, when the sand grains were being dumped into the Nanaimo. So yes, today the Nanaimo Basin is up here in British Columbia. But I think the Sandra Wild, Paul Umhofer strike slip fault reconstruction business, I think those faults are all younger than 50. That's my first question. Is that true or not? That's a new thought. I think that's post 50, younger than 50 to actually get this up here. I'm not talking about Baja BC now. I'm just talking about known faults and restoring to where the Nanaimo was in the most simple way to kind of put it together in my mind. I'm not pushing back on anything. I'm just trying to reason it out. So if we like Nanaimo in Oregon, and this is what Link and Mahoney were proposing, and we agree that rivers are taking sediment from the Lemhi Basin, and I think everybody is. I think everybody now, including our guest today, the two zircon specialists today, are seeing that the old PCers, remember that? Old PCers are going back to the Precambrian. Old PCers, you can't even read that anymore. I should have highlighted this again. 1700 and 1380 million years ago. Those are the old PCers. The old PCers, 1700 and 1380. The detrital sands in the Nanaimo Basin today, their cores are these blue dots. These old PCers, for our discussion today, they're coming from the Lemhi Basin of the Belt Supergroup in central Idaho. Okay, well, I thought before this month, before this series, that there was going to be a massive debate on the blue. But I think I learned from our guest last month, 2 months ago, that we're working with the idea that these old PCers are coming from the Lemhi Basin. Okay? So then our attention with Will and Danny turned to the rims. Do you remember this now? The red rims, these are my colors, the red rims are magmatic rims. Almost every one of these old PCer grains in the Nanaimo has a magmatic rim or a metamorphic rim. And as I watched the replay, I caught from Will that the metamorphic rims, at least, are high grade, meaning there were high temperatures and pressures involved, and that high grade metamorphism was between 95 and 72 million years ago. I guess my question is, are there metamorphic rocks that are high grade and magmatic rocks of age I don't know, maybe Will does, that are from Idaho? And if not, please remind me what I want to do with those rims. Do those rims, do the metamorphic rims mean that the grains were out of Idaho and then sent someplace else and incorporated into some sort of metamorphic rock, high-grade metamorphic rock? I think that's what it was, but I'm getting confused now. A different way to say it is remember the chronology here, and this is what we know from these guys. The Nanaimo Basin is a bunch of sedimentary material. It's not metamorphic at all. It's a bunch of sand grains, arcosic sand, between 90 million years ago and 63 million years ago. This is review now. And between 90 and 84 million years ago, the first 6 million years of time in the Nanaimo Basin, we are not in the water. We're not underwater. This is a non-marine deposition, and we have nothing but local sand grains. coming from the Coast Mountains Belt, coming from the pizza boxes, the San Juan Islands, coming from Wrangellia. That's what the yellow dots are, local neighborhood sands. But as Will in particular emphasized, between 84 and 63 million years ago, that's 20 million years worth of time, we have steady, homogeneous, old Precambrian grains being dumped into the Nanaimo Basin. And that sounds pretty important. And I wonder if that means that the Nanaimo is even moving during the time. Why would you have 20 million years of steady dumping if we're moving the Nanaimo during this Baja BC time? Or, you can see what I'm wondering here, and I think this is where we were leading in December, is the source of the Nanaimo in lockstep with the Nanaimo? This is Danny talking now back in December. Do we need to move, if we're going to move the Nanaimo, aren't we moving the source with the Nanaimo? Do you remember that? And I didn't really know what to do with that kind of idea 2 months ago. But what have we been doing in the last 2-3 weeks? Especially the Ribbon Continent guys are wondering if there's a major Tintina-like fault way to the east of the belt. And therefore, if we are moving everything, we're moving it on this Ribbon Continent fault, quote unquote. Last comment before we go quickly to the papers and then we go to our guests. This looks really exciting to me and saying, oh my God, we got a smoking gun. We've got stuff that's very old and very diagnostic, and it's right here in the Nanaimo. And then Will went on to say, I don't know, is it diagnostic? We have found old PCers, 1700 and 1380, Precambrian detrital zircon grains in all these places. It's a scattershot thing. How significant is that then? Why is it so widespread if this is the source? He goes to the laptop to show the papers that have been selected by our guest today. nickzentner.com. Click on Baja. And we have 5 articles for you today, 3 of which you've already seen. So this is the brand new paper from early December that Will hustled to make available to us. And Marie, the master's student, was working under Will's supervision. And you see Danny's on the paper as well as Stephen Hubbard, the professor who was supervising both Will and Danny as grad students. Okay, so that's not a new paper, but we might be referring to it. Here's from 2020. Again, you can see the co-authors, same cast of characters, Danny, Will, Marie, the grad student, Stephen, and a couple of others. What is new, this isn't new either. This is from the Joanne Nelson show, where she wanted to share this nailed to the Craton paper, looking at Cambrian rock. Now we're getting into Mitch Mihalynuk country here. And Mitch knowing BC better than most, and Mitch knowing the Jurassic events, but even earlier stuff as well. This is the one that's new that Will suggested I post a couple of hours ago. Late Neoproterozoic to Cambrian detrital zircon facies of Western Laurentia. And we may be referring to this paper as we discuss. In fact, I'm almost sure we will. But my God, we are in Utah, we're in Wyoming, we're looking at detrital zircons everywhere. Wow, okay. And then Mitch, who we definitely want to involve in a major way in our discussion today, wanted to make sure that you guys see one of Mitch Mihalynuk's favorite maps, tectonic map of the Indonesian region from 1979. And Mitch says that this has been on his wall for years as inspiration and ties nicely with the tectonic story, the tomotectonic, the tomography, the fixed archipelago, all that stuff So those are our resources that wait for you, and that frees us up to do some discussing back and forth. 16 minutes, a little longer than I wanted, but let's go ahead now. We're going to bring Danny in first. Jerome's still in the live chat. That's a comfort. Jerome, you haven't fallen asleep yet. Good job. All right, Danny, let's see if we're functional with you. Good afternoon, Danny Coutts.
Hey, Nick, how's it going?
I'm doing great. Your audio is particularly good, so thanks
Excellent.
for that. What were you doing this morning? Were you working hard on your day job?
Yeah, I'm still at the office, but.
Okay, good. Well, in downtown Vancouver, BC?
Yep, I'm just in one of our nice kind of working rooms where we got some light tables and some real good geology tools.
Well, I appreciate your time today, and you were enthusiastic about doing this, and you're the one that suggested we should involve Mitch, and I'm grateful for you to do that. So thank you. Let's bring in Will right away, and we'll just get both of you guys on screen. Hi,
Hello.
Will. How's it going today?
Good. How are you doing?
I'm doing fine, and you're at home in Calgary, I presume?
I am, yes. Yep. Same place as usual.
Same place as usual. Well, good. Well, we're going to bring Mitch in just a bit, but I don't mean to derail or anything like that, but can you remind me, either of you guys, about the role of those rims? Like, you were very sure that you had both metamorphic and magmatic rims, and they're younger than 100 million years ago. What am I forgetting about the importance of those rims?
Danny, do you want to field that, or do you want me to field that?
No, you do the rim stuff.
Right. So the rims provide us with another provenance indicator. So the cores, they tell us where those grains ultimately come from, and they tell us they come from Proterozoic basement of North America somewhere. And there's some places you can point your fingers to, the Yavapai and the Mazatzal origin for that older 1700 stuff. That's like mostly Colorado and that area, Utah. Yeah. And then bits of southern Utah anyways. And then the 1380s are coming from this intrusive suite that's found throughout the southern United States. And it's been fairly well documented since the 70s that this thing existed. And so those aren't particularly characteristic of any particular spot. But once you take that sediment that contains those cores and you metamorphose it and put those rims on those grains, now you have another provenance indicator, right? We need a rock that contains those core ages that underwent metamorphism and melting at the time that we formed the rims. And so this gives you another sort of a more powerful indicator of the provenance, the immediate provenance of those grains, where they came from. We know they originated in the Laurentian basement, but they had to have gone through this metamorphic process somewhere along the way before they got to the Nanaimo Basin. And then
do you know enough about central Idaho bedrock geology to know if the magmatic and metamorphic history is, if central Idaho has all three of those things?
Yeah. So it is. So one of the places we think that you can get this unique combination is the Lemhi subbasin of the Belle Purcell Basin in central Idaho. And the combination of Mesoproterozoic sedimentary rocks, the Belle Purcell, that contain that 1700 MA population. And then those rocks are intruded by 1380 MA granites. So that you deposited the sedimentary basin, and then these plutons came in and intruded it. That it could be the core population. And we think there's a reasonable chance that the cores come from the Lemhi subbasin. The question is the timing of metamorphism of the Lemhi subbasin compatible with the timing of rim growth? And when we look at the literature, what's published and what's available for us to know about that, it looks like the Lemhi subbasin was being metamorphosed too early. So it started before 100 million years. There's garnet ages and whatnot from the Lemhi subbasin that are like 110 plus. So that would be sort of indicative of earlier metamorphism than we see on the rims. And much of the Lemhi subbasin is low-grade rocks. They're not particularly hot. There's been no garnet growth in them. They're low-grade, and so they probably wouldn't grow rims. And people who have done detrital zircon studies on those basins have found rims in some cases and not in others. They're not universal. And so it sort of depends from sample to sample. the weird thing about the Nanaimo Basin is that basically every old PCer has a rim on it. And that's kind of incompatible with what we know about the Lemmy Subbasin and the zircons there. They don't all have rims. So it feels like those need to go through some other sedimentary rock, get metamorphosed, and then end up in the Nanaimo Basin. But we could be proven wrong on that. I mean, that's that's the thing. That's why we proposed that test.
That's what I'm hoping we can do today. Like just stumble into, not stumble, but like eventually get to places that we're hoping future folks can work on. And Danny, can you remind me what your role to this point has been in the Nanaimo different than Will? I remember that Will was doing a lot of lab work. Were you doing lab work as well?
Yeah, Will might say that I was doing lab work poorly at times.
Adequate, but did an adequate job.
Adequate. But yeah, I did a lot of field mapping of all the stratigraphy and the sedimentology out in the basin for the Upper Nanaimo group, and then did a lot of the sampling to bring those back, and then processed those for the 2020 paper that we wrote together. And yeah, on our original trips out there, we took these absolutely ginormous, like microwave-sized block samples of sandstone, which are like far too big than you normally would. We loaded them in the back of the small rental car, drove them back across the mountains, and then but we ended up with so much zircon that we could easily go back and just like grab the vial of this sample. So it's like we don't have to go back out and grab it. We just like take it off the shelf and just make new mounts out of it, and we could kind of continue doing these tests with the exact same samples, which was awesome.
Well, that's so that approach, your microwave-sized blocks, I'm getting the impression these other places that have these old PCers from California up to the Yakutat, there hasn't been that kind of sampling done yet. Would that be one approach, that people could be finding microwave-sized blocks from all these other places and doing the same exact process?
Yeah, and I think that'd be something that's really interesting, because I think that's something that Will has run into an issue with some of the underplated schists in California, that some of them, I believe it's the Salinas, is on private land. And so that's just like pretty much you can't access it anymore. And so
the owners got tired of geologists knocking on the door and saying, can we come in and study your land? And I think it's now hard to get access to some of these places. I think actually to make a comment about the, how we work together, one of the really great things about having Danny on the team was I'm a lab geek. I like shooting lasers at things. I'm really, really happy in a laboratory environment. I'm not particularly a field geologist. And it was really great having Danny involved to be able to like do all the hard work in the field, measuring all the sections, locating all the samples, figuring out which samples we needed. That was a real benefit to the project, because that's not something that I'm particularly good at. And so it was a nice sort of complementary skill that, we knew where the samples were coming from. We were getting the right things. And then we had a good, lab to make the measurements.
One more thing before we bring in Mitch, and then I'm going to eat a ham sandwich, and you guys are just going to go. Danny, is it so let's say we wanted to go to the Hornbrook, whatever, and do the same kind of sampling. It's not as simple as showing up and knocking off a few blocks and driving up to Calgary. Do you need to do the whole stratigraphic column and do 2 summers worth of work, do you think? Or has much of that work already been done? Or do you have any sense of that at these other locations?
Yeah, I think that's one thing that is really unique about our approach that we did for the Nanaimo Basin, is that we really tenuously mapped out all the individual kind of sedimentary systems, all these different deep water channels, to figure out where they sit relative to each other. Because in a lot of cases, they were just tied lithostratigraphically together. So it's just this is a conglomerate, that's a conglomerate. So we're just going to make it kind of layer cake. And what we've shown, and especially with the paper that we're working on right now, is that these systems, even though they're the same lithostratigraphic formation, because their individual channels have, in some cases, very different ages. And so as you start to pick out the stratigraphy a lot better, you can start to recognize what those individual, say, channel systems mean based on their fill, maybe their aspect ratio, if they're like really broad and narrow, really broad and thin, or really like tall and narrow, because all those things have meaning in the geologic record, or how well like amalgamated, how much they overlap. And so we can start to really put together a more complex and like detailed picture as to what's going on when we tie those methods together.
I mean, without knowing anything, I wonder if the floor drops out at 84 in all these other places too. Like, is there any sense of that this massive influx of these old PCers is happening simultaneously all up and down the coast?
So it is interesting that we get these things in rocks. The old PCers show up in rocks as old as like 91, 92 million years. So the beginning of the Turonian in the schist of the Nacimiento schist.
Okay.
So that's way down in California. But there is a lot of these things showing up around that time along the margin, but it varies a lot. So you mentioned the Hornbrook Basin. It has a few of the old PCers in it in one unit in the Hornbrook Basin. It's not widespread, but there's a unit that a couple samples came from that look like that. But I think it's a little bit younger than 84. I can't remember offhand exactly the age because I haven't read that paper in a while. But they are widespread at this time. And then the question becomes, are they widespread because the rivers went everywhere? Or are they widespread because the rivers went to one place and then tectonics moved them everywhere? And that's where you get into the different models for how you put the Cordillera together. And that's why I like that you brought up that list of all the places you find them, because it's, to be honest, they're found from southernmost California to the armpit of Alaska. Like that is a huge range of places. And in our 2022 paper, we have a list of where all these things are and how old they are, and where the publications are that they come from. But yeah, it kind of makes you wonder, right? Like, how definitive is the detrital zircon data in terms of drawing paleogeographic maps, of the Cretaceous and trying to figure out where all these terrains were, because those things are exposed along, I think, like 3,000 kilometers of the margin or something stupid, like 2,500 kilometers of the margin. So what do they actually tell you? And that's why when we saw them everywhere and then they had these rims, we're like, okay, we need to go to that extra step and see what these rims mean. And now what we need to do is we need to do that same work on all of the other deposits to see if they're in those deposits as well, right? Do we always find, where we find the old PCers, do we always find the rims? And that would tell us that that's coming from the source. Maybe that's the Lemhi subbasin. And if we don't find that rim population everywhere, then maybe that's unique to the Nanaimo / some other things that I'm going to talk about maybe in a minute. And that would be then some kind of paleogeographic tie.
Oh, this is great.
And one more thing.
Please, Danny. Yeah. And
like, if everything comes from the Lemhi and that's where we get the rims, and that's where everything comes from, the Lemhi is not a particularly large place.
Right.
And so if we think about like the ultimate source of these rivers cascading all over North America, coming from the Lemhi subbasin, feeding like out across the mountains through the Proto Cascades or whatever into the Nanaimo Basin, all the way south into California. These are some like probably pretty big rivers compared, like looking at like what percentage the old PCers make up of the zircon population. It's like 50% of the zircons. That doesn't mean it's 50% of the sediment. But like we're talking about really big turbidite channels that are hauling a lot of this sediment that makes up a large proportion of the population. And then that goes for like the Fork of California at the northern end and all this kind of stuff that's coming from like a relatively small map block.
Yeah, and you can't even just look at the Lemhi subbasin itself, because the Lemhi subbasin itself is, a few hundred kilometers wide and a few tens of kilometers across. And but only the very western edge of it is actually high grade metamorphic. And so, if the rims are all coming from the Lemhi subbasin, then it's only really that western part of the Lemhi subbasin, right near the Western Idaho Shear Zone, that could be the source as well. So you end up in this kind of weird, like, okay, that's what the evidence suggests, but wow, it makes it kind of weird. and I agree. You also need a distributed fluvial system, right? That's going not I'm going to go way outside of my expertise here, and Danny's going to chuckle in amusement to himself as I start talking about sedimentary systems, but degradational fluvial systems, right, where the landscape is eroding, the sedimentary system tends to funnel down to a river, which then delivers sediment to a basin at a point source. Distributed fluvial systems go to multiple points. So as you go downriver, the rivers become smaller and they become distributive. So imagine like a delta, how the river will spread out onto a delta and feed different parts of the delta lobe at the same time. So the Lemmy subbasin would have to be acting as a distributed fluvial system with channels going from this limited area to different parts of the margin to deliver all these sediments, which is why it might be simpler to take all the sediment, dump it onto the margin, metamorphose it, and distribute it tectonically than it would be done to explain a sedimentary system that can go to all these disparate places with the exact same sediment.
Wow. Okay, well, this.
How did I do, Danny? Did I butcher that really badly?
No, it was great.
Okay.
Big city daddy in his high rise in downtown Vancouver. Love it. All right. Well, I think it's time to bring in Mitch. And viewers, please remember now that in the lower mantle, this folded ocean floor material, these ocean slabs, and a proposal of westward subduction to get rid of some of that ocean crust. Now, how in the hell would that have anything to do with what we're talking about right now? I'll bet you these guys have a way to take that fixed archipelago model and get it right into this flow of the discussion. So let's bring in Mitch. Mitch, how are you today?
I'm great, thanks. How are you, Nick?
I'm doing wonderful. Thank you for joining us so much.
Will. Hey.
Hi.
Good to be here.
Yeah. Do you guys collaborate at all, or is this kind of almost a first meeting between the three of you?
Not nearly enough.
Good.
So Good. we decided, Mitch and I decided that we met at an AGU about probably 8 years ago, and actually Mitch put me on to an interest in some rocks in southern Vancouver Island that we've actually gone and dated, and that's sort of the paper that I'm working on now, the next big thing from our lab. So Mitch played an outsized role in my research program, considering the limited interaction we had once.
well, that's a goal for us today. Let's come up with another direction to head. Mitch, do you deal with detrital zircon at all? And if you have, what vintage are we talking about?
Nick, I think detrital zircons have kind of revolutionized the way that we map. I'm principally a mapper, so I go out and field places that we deem haven't been mapped in enough detail. Normally, these are areas that have some economic mineral potential. And we used to totally rely on fossils in order to get an idea of the age of sediments and or metamorphosed sediments. And now with the advent of single crystal detrital zircon geochronology, we can get an idea, at least a sort of a maximum depositional age, so older limit on the sediments. And that is really transformative for us in the field. And the area I'm working in right now is the southwest corner of the province. And interestingly, it hosts the package of rocks we're most interested in is called the Lardot group. And this Lardot group has been at the center of a controversy that has brewed since the early 90s, when a good friend and colleague, Moira Smith, did her PhD partly in that area. And she reckoned, based on some of the earliest detrital zircon work that was done, which relied on just the largest single zircons you could find, or groups of zircons that looked the same that could be amalgamated into and dissolved into an aliquot that was sufficiently large to be analyzed with the equipment available at the time. She reckoned that stratigraphy was upside down. And the work that we're doing there, looking at, sort of 2 or 3 generations of detrital zircon dating newer than what she and her advisor George Gerolds did, we're coming up with the same answer as
Wow.
Nice.
So it's not definitive yet. We just have hints that yes, Moira and George were right, but without detrital zircons, we wouldn't have a hope in those metamorphosed rocks. So you'll hear people talk about, you know, this package of rocks and whether or not they were sort of nailed to the craton. Well, if we've got the stratigraphic order upside down, then chances are there's something wrong with our interpretation, and we probably shouldn't be stepping out there and saying, you know, that those rocks are nailed to the craton.
Wow. Okay. Oh my. Well, I want to step back. In fact, I think I even want to get myself off screen at some point, because we'll get back to you three heads. I'll still be able to listen and I'll pop in like this, but we're so small now with these, and I want to get you guys chatting. And I saw we did a little bit by email ahead of time. Who wants to get us started? Did Will and Danny have some questions for Mitch, or vice versa? Or do you guys want to reflect on the series? However you want to do this, I'm happy to follow whatever direction you want to go.
Well, I have a question. You know, Mitch has put a bold model out there. It's bold, and I like it. You know, there's aspects I like. There's aspects that are tricky. You know, where do you see, like, you know, where are the big tests? You know, because every model needs to be testable, and how do we generate new data? You know, particularly interesting for us because we're sort of detrital zircon people. Although Danny's a sedimentologist too, but I don't hold that against him. But like, what kind of thing could you see to test that model?
So which model is this? We're talking about Moira's inverted stratigraphy?
No, your big model with Corinne. Yeah,
the Western Archipelago. Yeah, I've wondered about that in terms of detrital zircons, and you know, I have a question about using detrital zircons as well. Some of the detractors of this idea of westward subduction say that, because we see old Laurentian detrital zircons on both sides of where the trench should have been, that negates any possibility of there having been westward subduction. And yet, you know, in the case of good modern day examples of where we have relict basins between continents like Australia and arcs complexes like the Banda Sumatra arc, we see an abundance of ancient zircons derived from the continental source on both sides of the basin.
Mm-hmm.
So how good a test is this existence or non-existence of old PCers, if you will?
Mm-hmm.
How good a test is that for or against westward subduction? Would be my question.
Yeah, and I think starting with I'll go
ahead.
first because you will probably actually have the correct answer. But I think the use of the modern analog is like so poignant in that, because you can be like, oh, these are like cratonic Australian ages that we're finding very far from their source, where they pretty much probably shouldn't be. But yeah, thinking about like what these ocean currents and that sort of thing can move around. Yeah, we can move a lot of sediment probably in a lot greater distance than we expect. And then especially as you winnow out other kind of less mechanically hardy species like clays and softer minerals, that you might be able to actually aggregate those into a significant amount to be able to find them. And then you try to do that with less context of the actual geography, and you crush these things together in terrains, and it gets extremely difficult to sort those things out. And I think a big part, kind of what we opened with, is like a lot of times we use these lithostratigraphic correlations to be like, this is this, And now we're starting to do that with the treadle zircon signatures, be like, oh, sandstone A, sandstone B have the same like age population. So yeah, we start to really muddy the waters there.
Yeah, I think I like to call them facies. Just like you have sedimentary facies, which are sort of reproducible characteristics of, sedimentary geology of a rock. You can have a detrital zircon facies, which is like it contains the same sort of populations in the same proportions. That's why I use the term in that paper we put up this week. I think, so Danny kind of came at that as I expected from like the sedimentology, stratigraphy, how far could we transport something off a craton? And that is an enormous distance. Like fans go a long way out into the ocean. And if you're talking about westward subduction underneath, an island arc out there, then, those are going to get incorporated into the accretionary prism. And they're going to get, if the accretionary prism becomes emergent, they're going to get recycled into a four-arc basin on the backside of the accretionary prism. And so there's lots of ways that, you can imagine transporting them across, an ocean basin and putting them where they technically shouldn't be. But the other thing I would bring up, so that's the sedimentology side, but the other side is like, how definitive are these correlations? I know the Gravina belt probably gets brought up as a, because you've put where you'd like to put the suture between your arc and what was North America, goes through the Gravina belt. And the Gravina belt, so for people who don't know, is sort of like, it's in southernmost Alaska, sort of in the Panhandle, and it goes down into British Columbia. And it's right in the sort of heart, right between things that we see as insular superterrain in that part of the world. It's the Alexander terrain that's outboard of it to the west. And the inboard side is the name's gone out of my head. It's not Stikenia, but it's the Yukon-Tanana. Yeah, Yukon-Tanana inboard of that. And the Gravina stratigraphy has been, it's only exposed in little thrust sheets along this suture, I'm going to call it the suture because it's what we're talking about, but it's along where the suture would be in this model. And they've done detrital zircons on both sides of it. And there's an eastern facies and a western facies, and they look different from the detrital zircons. And it looks like, the eastern comes from the stuff to the east of the basin, and the west comes from stuff to the west of the basin. But, when I look at those detrital zircon populations in those rocks, the stuff that's coming from the west is really clear and definitive, and you could really say with fairly high confidence it's coming from Rangelia, the basement to the west. But the stuff from the east is pretty generic and lacks a lot of the detrital zircons that we'd expect from the Yukon-Tanana. So that kind of, that gets held up as like this sort of is an argument against the archipelago model. And I look at it and I go, well, it's a terrible test. And that's often what we end up with the detrital zircons is we end up with like, hey, these sort of match those things, like rock A kind of looks like rock B, and therefore, these go together. But like, even if you look at Laurentian basement, how characteristic is Laurentian basement in the world? And it turns out if you go looking around the world, there's Archean cratons with, Paleo-Proterozoic orogenic belts stitching them all together all over the world. So, if you take sediment off of Laurentia or you take sediment off of Australia, there's little differences between them, but it's not like, obvious, wow, this one looks completely different. Now, I haven't looked at a lot of different basins in different cratons, but still, yes. Nick, you've got your hand up. Yes.
Yes, I do. This is just what I was hoping for, you guys. This is perfect. I suggest Mitch shares his screen right now. We zoom out just a bit and look at a modern day fixed archipelago type of a scene. Talk about why Mitch is enamored by that map of Hamilton's. And then we'll eventually go to Will sharing some of his slides as well, kind of switching gears again. I hope this isn't too all over the place for you viewers, but I'd like to try it this way. So Mitch, I find your cross section, sorry. So the map is waiting for you at the website, which I showed you, but let's try to bring in Mitch's cross section. There we go. So Mitch, can you help us see what's here? Kind of remind us about the model that you and Karin have, and maybe tie us into a little bit of what we were just talking about with Will and Danny.
Sure. Does that help at all? Did that make it bigger at all? Probably not.
Yeah, I can even let me try to just get rid of us. I don't know, that might make it a little bigger. Yeah.
Anyway, so this is probably the world's archetypical continent arc collision zone. And what it shows, if you look at the map, that's northern Australia in the bottom, and it's colliding with the Banda Arc. And you can see Papua New Guinea up in the northeast corner. It's being sheared off by the Pacific Plate coming in from the east and wrapping that Banda Arc around to the east. But the key thing here is along that about 14 or 1500 kilometer collision zone, you see involvement of the Australian continental margin. Mm-hmm. And that is dominantly sediments, so that were deposited when Gondwana broke up. So these are Permo-Jurassic sediments shown in the cross-section in yellow. And overlying that are what I've sort of colloquially called here suture basin sediments. This would be sort of the Australian passive margin. And there are a whole bunch of things happening at once. That Gondwana sequence, which interestingly is characterized by two detrital zircon populations, one at 301 and one at 1882, is being thrust well beneath the forearc of the Banda Arc, such that if you look at this, so this is the level of erosion now, if you can see where my pointer is. Mm-hmm. So right now you actually have exposed on the sort of outboard side, so away from Australia, you have exposed blue schists in this area and eclogites. So these are high pressure, low temperature rocks that are markers of subduction. And then you have arc rocks to once again, the outboard side. And you have this melange belt. You know, you can think here maybe the Franciscan and a piggyback basin like Will was talking about. This might be something akin to the Nanaimo, and this suture basin, which of course would contain zircons recycled from the Gondwana sequence, as well as those that had been eroded from Australia in more contemporary times, and then folded, duplexed, so thrust up into many sheets and piled up. So each one of these little worms is a thrust sheet of that Gondwanan stratigraphy. And you can see there's a tremendous amount of shortening represented. These are all thrust faults. And this is the subduction surface. So this is the subduction zone now. And you can imagine how that subduction zone has migrated along each of these surfaces as the Australian continental margin is plated onto the Asian plate, and the trench moves away from the Asian plate towards the Australian plate. All of this, what used to be Australia, but has moved by a conveyor belt to Asia, is now part of the Asian plate. And eventually, Australia will collide, and this whole arc will then become part of Australian plate. And you can actually see in the GPS measurements that is starting to occur. This part of the Banda Arc is starting to move with the Australian plate. So that's cool. a modern example of sort of the mature end member of this archipelago override that Kevin and I like to talk about, and why we think that, you know, the Laurentian, or in this case, in this example, the Australian detrital zircons on both sides of the basin, or the lack of them, it is not really a good argument against the archipelago override.
Yeah.
Did you guys have anything you wanted to ask, spitballing off of that, or if not, I'll have one, and then we'll transition back. I mean, viewers, we're coming to you eventually, viewers, but it's the first time we've tried this. We're just kind of, instead of scripting everything out, I just wanted to have it be as spontaneous as possible. And so occasionally it'll be kind of like, who's directing this thing anyway? What the hell's going on? So I'll start, and then we'll see if Will and Danny want to add. So back to thinking about North America then, since we were just looking down there. Mitch, I'm wondering, are you a mega whale person then? Are you wanting that major, where is your suture? Is that an important part of this ongoing discussion? Are we looking for, you're talking about that suture place, and then it's migrating as we continue to collide. I think I'm getting that from you. What parallels, based on what we were just looking at, can we think about with Western North America?
I think we have to take a sushi knife and slice up the whale, Nick.
Okay.
And some of the motion. Yeah, there it is. Sorry, whale. You got to be slicing down the middle. I think a big chunk of that motion has to be what's called in the past intraquenelian. So it has to, let's call it intramontane. And I suspect that a lot of it needs to be accommodated along the Cache Creek terrain. Where it goes in the north end, I don't know. Where it goes in the south end, I don't know. What we need desperately is to drag Randy Enkin away from doing chronostratigraphy in marine sediments and get him back drilling hard rocks and doing some more paleomag in the Cordillera. We need to figure out, which parts of the intermontane superterrain have moved preferentially. One of the last conversations I had with Ted Irving before he passed away was with regards to the quality of the paleomag in the intermontane, in particular in the Quenelian terrain. So that would be the inboard half of the intermontane superterrain, and he reckoned it was all compromised by overprinting. So we've started to resample some sections good sections that we've come across in more recent mapping. Those paleomag samples are sitting at the University of Oslo right now, and we're hoping to get some results from them one of these days.
Cool. New paleomag in intermontane. What kind of age of rock?
So we've sampled rocks that are latest Triassic, earliest Jurassic, as well as some more of rocks that are about 103 million years old. So these are the Spence's Bridge.
Mm-hmm. Mm-hmm. Cool.
And these are from sections that were discovered during mapping that sort of post dates the major paleomag campaigns that were conducted in the earlier days.
So based on my reading of your papers, I sort of, when Nick was posing, are you the mega whale or a smaller whale? I was pretty sure you were going to end up with two pieces. There's the intermontane-ish piece that does its thing, and then there's the insular-ish thing that does its thing, and then they meet at some point. And I think that's really compatible. I mean, you'll have Basil on next week. His model is the same way, right? There's two pieces. One's further traveled, one's lesser traveled. And that kind of fits with your preamble where you're talking about how there was a gradient of apparent displacements from the paleomag across the Cordillera, with the insular looking like it's traveled a little bit further, and the stuff that's more inboard traveled a little bit less distance, and that's why Basil, I don't know how you say his name properly. Is it Basil or Basil? Has anybody talked to him recently? And okay.
Either one.
I'm just gonna oscillate back and forth saying it one way or another, just so I pick them off either way. And I think that's why he came up with the model he has too. That there's a further traveled block that meets the more intermontane-ish block, and then they move together further north to accommodate the Carmax volcanics. And it's very interesting you're talking about like the interquinellia displacement, because the mega whale, the ribbon continent models, they push that really, really far east, right? And I've always had some discomfort with that. Before I went to do my PhD, I was a petroleum geologist working in the oil patch in Calgary, and we would take our well logs from our wells that we drilled in clearly North American places, and we could trace them, across the mountains, like Margot McMecken has done in that Nailed to the Craton paper, right? And it is really, really compelling correlations all the way back over the Lewis thrust onto the top of the Belt Purcell, and you kind of look at that and you go, geez, if it's the Lewis thrust, then the Fairholme sitting on the Lewis is identical to the Fairholme sitting under the Lewis, and that's a bit awkward. Things can be similar on other sides of an ocean basin, but not that similar. And so, when I started my PhD, I sort of stumbled in. I started my PhD in 2010. The two ribbon continent papers that just come out, they were generating a lot of excitement. People were like interested in them. There was this new idea. And so we actually studied them in parts of some of our courses, because my supervisor, we had actually Bob Hildebrand came to the University of Calgary and gave a talk to the geoscience department about his new idea from his 2009 paper. And so when I was choosing a PhD topic, I actually did a test of the eastern suture location. And if you don't mind just sharing my screen, I can show you kind of what I did. And this is this test is in that paper, the 2017 paper that's on Nick's website, the latest Neoproterozoic to Cambrian detrital zircon facies of Western Laurentia. I get dragged into Cambrian things, but I really did a Cambrian thing to look at Cretaceous problems. And so if you could share my screen. Have you got my screen there?
I don't see it yet. Could you share your screen and put it in my green room? I don't see it, Will.
I will share again. Just to make sure here. We're going to go to
Let me get Mitch's thing out of there in case there's a space problem. Oh, here we go. Got it.
You got it now? Okay.
Yep.
So I'm just going to really quickly talk about what we did and what we found. And it's like 2 slides. Anybody can understand. This is pretty quick. This is a map of southeastern British Columbia and southwestern Alberta. And roughly the brown stuff is stuff that's, in the foreland. It's young stuff, Jurassic and Cretaceous mostly, but some Cenozoic stuff in there as well. And the blue stuff is Paleozoic. This is the passive margin of Western North America. And we're going to look at this cross-section down here, which goes through sort of the Crow's Nest Pass area, near where the Frank Slide is, the southern route through the mountains in southern British Columbia, so number 3. And the good thing about this cross-section is it goes right across these red and green lines and blue lines. And these are the eastern sort of suture positions based on the mega whale models, right? So this is where Bob Hildebrand would put his. This is where Steve Johnson would put the boundary of Sabia. And so here's the cross-section. You can see this is what I was talking about with the Fairholme, Banff, Rundle, the upper Devonian to Mississippian succession can be traced from clearly sitting on basement of North America in the east, all the way across to where it's sitting on top of the Belt Purcell supergroup out here in the west. And this is the path of the Lewis thrust right here. So this stuff's in the hanging wall of the Lewis thrust, and this stuff is in the footwall of the Lewis thrust. And the suture between the ribbon continent in the Rubia model is this line here. So you can see how this is very difficult from a stratigraphic perspective. So we wanted to do a test using detrital zircons. And so at the bottom of the Paleozoic passive margin succession, there's a Cambrian sandstone. And that Cambrian sandstone is found basically throughout North America. There's this transgressive sandstone that marks the first flooding of the passive margin, between 570 million years in the north and 500 million years in the south. And the nice thing is that everywhere in North America, it's a sandstone, so we can get the detrital zircons from it. So that's what I sampled. And what we found is that there's a really predictable north to south variation in the detrital zircons we get from the Laurentian craton. So These are probability density plots, which all your viewers have seen before. They're just now turned on their side so that I can make this cool north-south picture and still compare things. And on here, this red line is the suture between what was Laurentian rocks on the right and what is Cordilleran ribbon continent rocks according to the Rubia hypothesis on the left. So that's Bob's model. And what we can see is that there is no change in detrital zircon facies as you go across that line. A lot of the same zircon populations that we see on rocks that clearly come from Laurentian basement are the same as we see on the west side. And where we see populations that are different, we can explain them as being recycled from these Neoproterozoic rocks, which are these gray lines underneath them. And so here we've got, the same populations in the east as we find to the west. We got the same populations in the east as we find to the west. And so we saw this as sort of a kind of a negative test for the ribbon continent model because, those models posit that there should be some kind of, big strike slip displacement along this boundary. And so it would be unusual at the scale of the entire continent that we checked, like the southern part of the continent, that everything should line up across that suture. And so we saw that as a negative test of the hypothesis. And so, as I kind of started off saying, detrital zircons aren't likely to be definitive, but we can certainly support or, I don't want to say cast shade, but, partially refute, some of these models because we can do tests like this, right? And this test was a huge number of samples across. I had to drive my truck all over southwestern United States. It took me months to collect all the samples and then years to process them all. But this is the kind of thing we can do with detrital zircons to try to test some of these models. What's a reasonable position for the suture? Well, this would argue that where the Rubia and Sabia hypotheses put it are maybe a little bit too far east. And so I like when Mitch says maybe it's further out here. It's in Cache Creek, Quinella. That seems more palatable to me based on the work that I've done in the past.
Mitch, please.
You're muted, Mitch.
Sorry, we would say the main suture is between intermontane and insular, but the translation of the mega whale has to be, a lot of that translation has to occur sort of between Cache Creek terrain, which is in the middle of the intermontane super terrain, and Kootenai terrain.
Because a lot of these rocks that are on the west side of this diagram, this is Kootenai. Like you're just inboard of the Kootenai arc, right? And so you're very close to, so all this stuff down here, this stuff is all, in the westernmost part, the easternmost parts of the Cordillera, but over the suture in those models. Yeah, sorry, I might have confused things. You have a suture that's well further east between the archipelago and the intermontane. Yeah.
Danny, can we get you in here? Did you want to spitball off of that, or did you have a couple of questions for Mitch directly about deposits or something? Will you by email?
That might be close to the end. I have
okay. Yeah.
But I can share my screen. That might kind of help with what Will and Mitch were talking about.
Good, thank you.
And so I took this figure out of the Western Canada Sedimentary Basin Atlas, which is an incredible resource for Western Canada, going from Archean all the way to kind of Eocene, looking at the different stratigraphic layers in kind of Alberta and easternmost British Columbia, and largely how they relate to petroleum resources. But chapter 2 is this beautiful kind of description of kind of the traditional model of the Cordillera put together by Ray Price. And so I redrew this figure. And so we can see, so we have time going up, going towards the present. And then the boxes here relate to the age of the stratigraphy in each one of the terrains, Bridge River and Friend. So that's like the Methow, Cadwallader, out to the Pacific Rim. And then we have the Laurentian platform going back towards the start of the Laurentian platform in 1600. And then these little boxes in irregular shapes kind of refer to the time at which they accreted to the margin in the traditional model. And then the irregular boxes are kind of like where they are from North American Craton out to the Pacific Ocean in each one of the kind of morphologic belts. And I've put the Rocky Mountain Trench on there as well. And so to what Will and Mitch were talking about is that the kind of Quinella, Slide Mountain, and Kootenai kind of all have these North American affinities based on kind of the traditional model, where part of the Laurentian platform partially like riffs off, creating the Slide Mountain Ocean, taking some of these other pieces with it, and then that's all assembled, like you were saying in your exotic terrain stuff, Nick. They're kind of intermingling out in the ocean, and then all of that is kind of reaccreted to the Laurentian platform. And so I did try to put some of our key, I started trying to put some of our key like overlap sequences, some of these key links like Churn Creek links, the Bridge River and Friends-ish with Cache Creek, with Stikinia-ish stuff. And then we have other sedimentary basins that overlap other parts, just to show kind of where these key correlations in time and space are, to kind of put to the test of like, what can we get out of these links, kind of, or like, where are the key links that we have to start thinking about? Because if we're linking terrains always based on chert pebbles, it's tricky. There's a lot of the Cordillera put together based on chert pebbles that are in certain ages. So I think that there's a lot of work to be done, and there's a lot of stuff that Mitch was saying is that there's large packages of the Cordillera that could be like kind of internally deformed, that would be hard to kind of discover or tease apart into those like nice mappable units.
Did you make that for us?
Yes. Yeah, and then I tried to put the different models kind of down below, where we would have the ribbon continent, kind of like Will was saying. We have some of these North American affinity rocks kind of on one side of the subduction, and everything else kind of assembled together.
Yeah.
Mitch can correct me, but the main kind of insular westward subduction would be kind of underneath the Coast-Batana complex and Wrangellia. I have no idea how like the Cadwallader and Metau fit in there. But then, yeah, in Basil's Hidden Run, we would have subduction going the other way. But I guess in Mitch's, we would have subduction this way and then flipping to the other way.
Well, there also has to be, we know this from the isochrons in the Pacific, we have to be consuming ocean lithosphere beneath the outboard side of that arc complex as well, because we have, the Pacific is growing and North America is moving it to the west and consuming the ocean lithosphere on the leading edge of it beneath that archipelago. But if that archipelago is fixed, as it appears to be based on the slab wall that is forming beneath it, then the Pacific that is growing from essentially the navel in the middle of the Pacific, we can see that from the isochrons, it has to be consumed beneath that intermontane, or sorry, that insular arc complex as well. So we also need to have some component of eastward subduction beneath that archipelago. That's why we call it an archipelago.
So what happens when the two slabs meet?
When North America forces that consumption of the intervening Angayuchum Mezcalera ocean basin that we talk about, it forces that closure, and then all the ocean lithosphere that's consumed at that point. Sorry, let me rotate my hand. No, let me see. Okay, I think this makes more sense. I don't know. This probably makes more sense. So this is the if this represents the Encayuchum and Mezcalera art complex, and North America is riding into it, and ocean lithosphere on the leading edge of North America is being consumed by westward subduction as it moves in. Once it collides, then you have extra consumption. That arc then is plastered to the leading edge of North America, and the ocean lithosphere, all that's being subducted then is ocean lithosphere being subducted eastward, because there is no ocean lithosphere left at that cusp between that arc complex and North America. So we go from westward and eastward to solely eastward.
One
That's
question
when you
Mitch is,
that's when you detach the ribbon candy and it starts
Exactly.
sinking.
That's when the ribbon candy, we can see it broke. We can see that it broken off at the cusp, but it's still being fed by westward subduction along the limbs of the chevron as North America rides over and shears it off.
Love it. Danny.
with your intermontane, Mitch, are you happy with like the general model of the intermontane and like
Of it having loosely docked by about 185 in the Canadian Cordillera?
Yeah.
Yeah, but I would say that it wasn't tightly enough amalgamated with North America to have North American crust beneath it. We know that from, once again, looking at zircons in plutons that seem to have been, are derived and cut up through that package, having no signature of cratonic material, derivation from cratonic material. So that's like the Hogan batholith. Luke Otis is working on that, if you're interested. But there's no evidence of an evolved source for those plutons. So it may have docked there, as my colleague Graham Nixon, I think he has a very good argument for docking around 185, but it's not tightly amalgamated with North America. There's the two there's still a lot of shortening to occur before intermontane is ramped up onto the margin.
Okay, I feel like we should go to the viewers. I know you had a little bit of Pacific Rim stuff, Will. How much of that would you want to share, or should we go to the viewers now?
If you give me 2 minutes, I could share the Pacific Rim. This is stuff that nobody has seen other than the people who are worked on it.
Oh my God! Okay, let's
Very
do it.
exciting. So
I'm
the
excited.
viewers will remember talking to Aaron Donaghy, who was working on the Tofino Basin as part of her PhD. And I'm hoping I didn't just butcher all that, but I think the Tofino Basin on this is this blue stuff in here, I believe. Oh, maybe not. Might have that wrong. But let's not worry about that too much. But anyhow, she so one of the other terrains out here. So the Nanaimo Basin's on this side of Vancouver Island. Everybody can recognize the shape of Vancouver Island, hopefully by now. The Nanaimo Basin's on this side in the Gulf Islands and along the edge of the Big Island. And so on the other side of the island, there's the Pacific Rim terrain, which is like a little enigmatic sliver of a terrain. It's exposed just in some very nice areas near Ucluelet and Tofino, and then in the south end of the island under thick forest in the Leech River complex. And of course, I think, Mitch, you live in Victoria, do you not?
Yes, just on the northern fringe.
Yeah, so there's a little bit of Pandora Peak Unit, which is part of the Pacific Rim terrain, which is right underneath Victoria. And so Mitch actually lives on this one. And we did some detrital zircon work on this because nobody had done it before, and we didn't really know how old these were really well. And we found some really interesting things. This is depth profiling work results, just like we've done on the Nanaimo Basin. So last time I talked to your group, we looked at the Nanaimo Basin, and we could see that there was all these yellow rims, there was all these gray homogeneous grains, and the cores that give us that signature from the old PCers. Well, we've also done that same type of work on the Leech River schist. So There's the Nanaimo Basin in the green. The Leech River Schist is just south of it in the yellow. And we find that we've got exactly the same zircon populations in the Leech River Schist. The Leech River Schist just gets a little bit younger than the Nanaimo Basin. This green band is the age of rocks in which we find these zircons. And so Leech River Schist tells us that that sediment source that was supplying those old PCers to the Nanaimo Basin, it continues to supply sediment to the margin until at least probably 58 million years. And then, very exciting, much further to the north, with John Garver, we've actually dated and depth profiled rocks for him from the Yakutat microplate, which is that microplate that's colliding into Alaska and creating the St. Elias Range, a lot of that high topography in Alaska and Yukon. And there we find the same zircon populations that we find in the Nanaimo group and the Leech River Schist. And so these are the same textures, the same types of zircons. And so what we think is happening here is that whatever sediment source was feeding the Nanaimo group into the Forearc Basin schlepped sediment over to form the Leech River Schist and also to form the Yakutat strata. But at that time, the Yakutat plate was down here, right? And Aaron Donahue talked about how it was potentially that the Yakutat and the Silesia terrain used to be one piece down here in northern Washington. And then the Yakutat plate broke off and translated north along the Queen Charlotte Fault to collide with Alaska. But we've got really strong zircon evidence to suggest that that is the case, that the same zircons that we find in the Nanaimo, we also find in the Leech River. So it looks like the sediment came out of the Forearc Basin, down onto the floor of the ocean, onto the Silesia terrain. The Silesia terrain broke into two pieces. Part of those zircons got underplated underneath southern Vancouver Island, became the Leech River complex, and then part of them went north to become the Yakutat microplate and be the Yakutat strata up in Alaska. So I think that's one of those things that zircons might actually be able to do well for us.
I mean, that sounds really good. I'm excited by that simply because I know at least a little bit about Yakutat and Silesia from Aaron. Mm-hmm. And if you guys are up for it, Aaron's in the live chat and I just emailed her a link. And are you okay if I bring her in?
No, that'd be fantastic. Sure. The more the merrier.
Okay.
Well, while we do that, maybe I'll ask Mitch my one question.
Please, go ahead.
So Mitch has, for viewers, Mitch has spent a long time looking at ore deposits across the Cordillera, trying to understand why they are where they are, and that's he alluded to that's how he kind of got to start working with Karen. But I have a question for Mitch about ore deposits, and that's how have these new tectonic models of the Cordillera changed the way you think about how ore deposits form, or how we might be able to use these new models of the Cordillera to find more ore deposits? I say from the head office of a gold company.
Great question. The money question. Excellent question. Yeah, you know what? My original foray into tomography was to answer, where are those big deposits like Bingham that sit so far inboard of the active plate margin? Where are they north of 49 degrees? Still haven't answered. Haven't gotten there yet. We're still trying to figure out how to read the mantle structure, trying to figure out what it's telling us and coming up with a toolbox that works in most cases. And I think we're just about there, but we haven't, and it's a pretty blunt tool. I mean, if you look at the supplementary info that mainly Corinne put together on a error analysis of this technique, this tectonic technique, the error bars are pretty big. Mm-hmm. So we need to pare those down, and before we can convince that the exploration companies that this is a good tool, or before I can even convince my managers that this is a good tool. On the flip side, the Australians, who I think have maybe eclipsed North Americans as as explorationists, no offense, but in general,
They have fewer
they're
trees.
using tomography in their exploration programs, like, ambient source tomography and such forth. They're actually putting seismometers in the ground to help them find ore deposits. And so I think we're on the cusp of change. We have more work to do at the end of every day, every workday, looking at this seismic tomography to help sharpen our tools. But people are starting to take note of tomography as a real potent exploration tool. So kind of a wishy-washy answer, sorry, but that's where we're at.
Mm-hmm.
Thank you for that. We have Erin in the green room. I'm going to bring her in. Mainly, I just want to see if we can get 5 people on camera at the same time. And then if we can, I'm going to hide Will and Mitch probably. No, I'm going to hide Danny and Mitch in just a second. So let's see if this works. Hi,
There we
Erin.
go.
How are you?
Hi, can you hear me all right?
Can hear you great. Thank you for being up for this. I mean, this is great. I mean, I don't even know if you were able to listen to what Will was saying, because I was distracting you with emails and everything else, texting.
Oh no, I saw it. I saw
okay.
I saw the slides.
Let's try this, and if we're still functional, what kind of overlap are you doing, Erin, based on what Will just shared with us?
Yeah, it was pretty exciting to see, because I'm just starting to get some new ID-TIMS data from the Yakutat terrain, and that's looking at these basal-most sediments that are sitting right on top of what the volcanic basement would be. So what we would be the equivalent to the crescent basalts, the Silesia basalts. So I'm looking at those initial sediments coming onto both of those terrains. And even before kind of seeing those slides and seeing some of the initial shows with Will and Danny, I was like, oh wow, their DZs, like they look like my DZs in the old well. And it looks like I have reworked Nanaimo into the Tofino Juan de Fuca basin. So yeah, the slide that Danny showed is the blue was the Tofino basin, and then the Juan de Fuca basin kind of extends to the northern Olympic Peninsula, and together they're called the Tofino Juan de Fuca basin. So yeah, it's really exciting that this is kind of lining up, because kind of what I presented at GSA too is suggesting that there's basal sediments that are sitting right on top of Silesia. Now what we're thinking is sitting right on top of Yakutat are these pre-accretion sediments that have been kind of brought in. So they're pre to syn to post collisional. And they're the ones that have these really similar signatures to the Nanaimo and stuff from the continental margin.
Well,
because one of the questions I'd have is the Leech River complex and the Yakutat rocks that we've measured are all Maastrichtian essentially, or earliest Paleocene. Most of them are, the youngest thing we found this in is one of the Leech River complex samples is 58 million years, which is still earlier than, your 52 million year sort of collision. And so how do these fit into the forming, like the timing of the formation of the Silesia and Yakutat? We really got to come up with the Silakutat terrain, or the
terrain.
Yeah.
I haven't come up with a good word or what's it called, the composite. I think I've written it as composite Silesia Yakutat terrain. So if how much of, I don't know what I'm seeing on top of Yakutat or on top of Silesia, how much of that sedimentary section is preserved and how much is missing after it has collided. And there are places, where you have varying stratigraphic thicknesses and different lithofacies, suggesting, maybe we can split apart these pre and post collisional packages. And as far as bringing Yakutat back down, Some of the preliminary age data, and I'll present this at the Spring Cordillera meeting, is kind of suggesting that, yes, the Yakutat terrain does have this early shared history with Siletzia, and some of those ages are going to push back to the oldest ages we have on the Siletzia Plateau, which would be around 56 MA.
Mm-hmm.
So we're still not quite to 58, but Siletzia, Yakutat kind of spans this 56 to 48 MA, depending on if you're in Oregon, how far apart or far away were you from this ridge-centered plateau.
I think this would be an awesome like 1-2 punch. If you do the detailed work on like the basement itself, those sediments right on top of it, and then you have this, this fairly obvious correlation between the Leech River, the Nanaimo, and the Yakutat. That should pretty much nail it down that it comes from here and goes north. That short translation that you were talking about, the other option, doesn't seem particularly reasonable in the face of all that evidence.
Yeah. And I mean, like on the Yakutat terrain, you have on that eastern part of the terrain, you have the Yakutat group, which is essentially just looks like that slivered off piece of Cretaceous accretionary prism that could originate down by the Leech River. So
cool.
And that's always been in my mind, like kind of that the evidence for the initial collision when this was a Siletzia Yakutat composite terrain, and we've slivered off a little piece of that, and now we're going to take it with us on this northward journey to Alaska. So.
Wow, crazy.
Okay, I mean, come on,
Nick.
now.
You look so happy. You look just so happy, Nick. You got like bonus guests. Is there anybody else in the chat that wants to come in? Who else we got in there?
Yeah, sure. Yeah, we got. I do, and it's 3:30. If Danny or somebody else has got to run, I understand, or Aaron as well. If you just want to pop back out, but whoever wants to stick around, we'll do. I think 15 minutes of viewer questions, just for anybody who feels like they want to. Does anybody need to take off?
No, I'm here for the long haul.
Yeah, we do.
Okay. Thank you.
Yeah, I'm
Uppercase viewers, please. You can. Come on now, the board is full. It's like Jeopardy now. We got all sorts of topics for you to pick from.
It's almost like Hollywood Squares.
Yeah, almost, yeah. We did Paul Lind in the middle. I just dated myself. Okay, so yes, and viewers, it'd be helpful if you had one of the guests' names, like Pat did a nice job here. So Mitch, is there any dextral movement in the Purcell Trench? Good to see you, U of C alum at the forefront.
Well, I guess Dino Pana would say so, and I haven't spent much time in that particular trench. Other trenches, yes, but not that one. So I can't speak from personal experience, but as I mentioned, Dino Pana, I think Bob Hildebrand showed an excerpt from one of Dina's recent papers that talked about those fabrics.
Thank you. Anybody can take this one. Kirk wonders, is there a smoking gun metamorphic mineral for a suture, much like eclogite for subduction?
Well, we would hope to see blue schists or eclogites within the suture. That would be the definitive suite. Those and maybe slivers of mantle, evidence that significant amount of ocean has collapsed and you have little relic bits of it still in existence.
Okay. Troy asks, Mitch, what role would the trench outboard of the island archipelago have in Baja BC?
Well, it would have an ongoing presence, and we should be able to find that. That would be one thing that we would predict, and so we should be able to find that. Whether I'm not sure whether there'd be anything really distinctive about it that we could use as a fingerprint, other than the time and that it should have dominantly oceanic sediment relics with it. Maybe some of the intermontane detritus would have, insular detritus would have made its way into the trench and become accreted. But for the most part, it would be, materials derived from the immediately adjacent arc and oceanic materials.
Mm-hmm. Trevor asks about the resurrection plate, relics of the resurrection plate. Does the new data here support that? Or does anybody want to comment on the role of the resurrection plate? Erin, you've been kind of thinking about that a lot.
Well, the resurrection plate is really this kind of 60 to 40 MA story where you wedge another plate in between the Farallon and the Kula plate. And that means you have a spreading ridge that is subducting from west to east beneath southern Alaska. And then also a spreading ridge that's kind of fixed to Washington, Pacific Northwest area. And this kind of came around with the Sanac-Baranoff belt that you see this west to east trend of younging ages and near trend plutons. And so that there's two ways to get that. You could have the fixed ridge down in Washington and you just translate a terrain northward and that would give you that same trend. Or you could have this ridge sweep from west to east beneath southern Alaska and it would be less terrain transport in that case and form that same west to east younging and near trend plutons. And so it's kind of this, okay, are we going to have this long or large scale terrain transport one spreading ridge in the Pacific Northwest, or are we going to have two? And that means you have to fully subduct the resurrection plate at one point. And you've had Spencer Fuston on in the past, who was looking at the tomography of this potentially subducted resurrection plate that's still sitting in the Yukon. So that could be some evidence for the resurrection plate. There's also been a lot of researchers who's worked in the sedimentary basins trying to document the response to spreading ridge subduction and how that would be recorded in the rock record in southern Alaska. But I think, those are two kind of, okay, we're on the opposite sides of this debate. We have the resurrection plate team, and then we have the team that we only want one ridge and we want the Chugach Prince William terrain to be transported all the way up, and that could account for that same trend we see in the Sanac-Baranoff belt. So it's kind of two schools of thoughts. It's almost like a younger version of Baja BC, but we're just taking BC up to southern Alaska between 60 and 40 MA. And I think there are just really kind of still can be debated two schools of thoughts on that.
Love it. Thank you. Joe asks, Will, timing-wise, does the Nanaimo pass the baton to the Yakutat to continue running?
Oh, I love it. That is a really well-phrased question. Yeah, it's like, here you go, and you keep going north. Yeah, that's that kind of seems to be how it is, right? Like, the Nanaimo Basin, that part of the insular, it all needed to be in place by 50, 55, 52, something like that, right? It had to be in place before Eudoxaletia, before the Flores volcanics are erupted, because we know from the Paleomag and the Flores, they're all in place relative to North America. And so you could see it as that, like it's a passing of the baton. Sure, yeah, the sediment, either eroded from the Nanaimo Basin or, from the same source of the Nanaimo Basin, got a little bit further outboard onto a piece that was going to continue on and run the next leg of the race, to the finish line in the armpit of Alaska. I got you a question for Erin. Does if we have good evidence that the Yakutat plate has moved north post 52 from down here, how does that impact our understanding of the resurrection plate? Because it should have some impact, right?
Yeah, it definitely would have impact. Like if you look at the original papers that were kind of like putting out that model, like the Madsen 2006 is one that comes first to mind for me. You would have to think about, and at the end of that paper, it kind of has reconstructions in different time slices of where the resurrection plate was and how subducted and where the spreading ridges were. And so it's kind of a model that is nice that you could potentially go and test that by doing field work or looking at near trench intrusions and the timing and the ages of all these things. But yeah, if we're trying to move the Yakutat terrain northward at the same time, you're going to have to think about, okay, if the resurrection plate existed, when did it fully be subducted? Because I need to get this terrain up to southern Alaska, and you can't really have this east sweeping ridge happening at the same time. You would really have to think about the timing of when all these different things are happening, because you can't have both happening at the same time. I think you would need the resurrection plate to be fully subducted before you could then start. And maybe that's okay. That's your plate reorganization.
Maybe it works out timing wise. Yeah.
I can't remember off the top of my head when they fully wanted the resurrection plate to be subducted. I know other people want the Queen Charlotte fault, which is kind of the main fault that's hypothesized to bring the Yakutat terrain up northward to initiate between 40-45 MA, and that's during a period of major plate reorganization. So if the timing of all these things work out, maybe, but we have to, once we really start to pin down the ages and when things are moving, that could help kind of resolve some of these tectonic configuration ideas we're thinking about.
Mm-hmm. Cool.
Very exciting. Very exciting. How about 3 more for everybody? Mitch, Jane wonders, is Salmon Arm Old North America or Intermontane?
Ooh.
Spicy.
Yeah, that is a spicy question. Good one.
Why is that spicy?
Well, because it's another controversy lurking beneath the surface there. My preference is part of Intermontane, but yeah, that's something we're actually going to look at in a little more detail. Sort of an outgrowth of the work we're doing right now on that whole Lardot group question. Is it inverted or is it not? And are there 2 Lardot groups?
Okay, thank you. Aaron, I want to thank you for this kind of strange impromptu thing. You're a really good sport for jumping on with this. So it was thrilled to have you, and thank you so much. I think I'll let you go right now, and we'll look for you down the road.
Thanks.
Okay,
Bye.
thank you.
Bye.
Bye. Okay, I think it's time for some closing thoughts from you guys, if you have any. If you wanted to, Danny hasn't been with us. Danny's probably working on his exploration work.
You can see that.
He's on the clock. I don't know if you felt like we kind of got roughly where you thought we might want to go, or if you wanted to be a little bit more specific about comments on earlier letters in the alphabet, or if you wanted to emphasize anything before we just kind of say goodbye. Your call, you guys.
Sure, I'll go first. I think that there's a bunch of things that people have kind of abundantly made clear, is that like everything's a lot more complicated than the original models make it out to be. Like Basil was like, oh, we like have to really make sure all these pieces get put together, and then it's like, oh, Chris is like, oh, we actually need to think in like geologists normally think in 4 dimensions, and so Chris is like, maybe we should add like depth or temperature. So if you add both of those, it's like a 5-dimensional problem, I guess. And then, yeah, building on what Mitch and Marty said, it's like we should really start thinking about how we kind of deform internally some of these terrains potentially, and how we might be able to accommodate motion on them, because as we look across boundaries between terrains, it always seems like somebody's mapped something that like links across. But a lot of those things should probably be tested, because we do have a lot better methods now than we used to.
Thank you for that.
And I think, like, if we look at even just, just east of Vancouver and north of Vancouver, there's a whole bunch of complexity in around the Harrison Lake Fault, and a whole bunch of sedimentary basins there that we have really rudimentary first first degree knowledge of an understanding of. We know roughly their age and their petrography, but really don't know a lot else about them. And there's a lot left to do. We still have, if you gave me, I think Danny, you were going to ask this question, but if you gave me like, $10 million, a helicopter and a lab and all the things to go and do, you could be busy for decades, with students wandering around in the mountains, collecting rocks and measuring things and testing a lot of these correlations. And, it's just time, money, and effort, right? To really sort a lot of this stuff out. And trees. What we need actually, this is going to be very not politically correct. I probably shouldn't go here. What we really need is a lot of really big forest fires to burn down the trees, let us get into some of these places. And I know that's not okay. I shouldn't be hoping for forest fires. But it really does make the geology so much easier to see.
That's why Australia is better at exploration. They don't have trees.
Mitch, can you save us here?
Yeah, I come at this as a mapper, and I'd just like to say that geology is so underconstrained that when we finally key into a good relationship in one area, we have a tendency to extrapolate that probably beyond where we should. And it gets us into trouble. Danny mentioned chert pebble conglomerates here looking like chert pebble conglomerates there, and hence we draw these correlations. We are bred to do that, and it's problematic. We have cases, we're talking about Cache Creek and having faults through Cache Creek. People will say, oh no, you can't run a fault through there because there's a middle Cretaceous pluton that pins that fault. Well, we go there, we're rooting around in the forest, and we find another pluton that has a shear zone through the margin of it, and that shear zone is folded, and that pluton is Eocene. So really, we're dealing with a very incomplete data set, and we just got to get on with it. And probably one of the best tools that I've stumbled onto is G-plates for forcing you to come to terms with spatial relationships. Now, the model that, the Clennet et al. Model that was published is also very highly underconstrained. And we also have the problem of, we decided to keep terrains in their present form just so people could follow them back in time. That's clearly not the way that the plate, the terrain history, it did evolve, but just for the viewer's benefit, that's what we did. Now that model, like every geological map that's made, I like to tell field assistants when they come on at the beginning of the season, the only thing that you're going to be able to say for sure about this map at the end of the season is that it's wrong. But it better be a lot better now than when we started. And so, that Clennet et al. Model, we can definitely say it's wrong, but it's better than the model that came before, which we also made. So say that.
But I think, I was going to say that I think that even improving on your own work and being like, oh, we can kind of like dunk on ourselves. Will's done that a bunch. That it's like not a problem. But I think that even like re-examining other people's relationships, like we've done in the Nanaimo, gone through and been like, oh, this is like not layer cake and that kind of stuff. Like I know the guy that mapped all that stuff back in the 90s. Tim's an incredible geologist, but it was just a different, that you looked through it in a different lens. They didn't know as much about deep water systems back then. And so I think that as we bring these new techniques, it's not necessarily proving things wrong. It's just like bringing a lot more nuance to the discussion.
Yeah. Well, I think I just want to end it there and say thanks to each of you. This was just really fun and kind of uncharted territory. I mean, I did have 4 heads on last year with the Dream Team folks, but we had a very specific plan. This could have gone south in a hurry, no pun intended. But it didn't, and you guys played off each other beautifully. And to bring in Aaron was just cherry on the top. So
a bonus guest, yeah.
Exactly right. So it was a pleasure to meet all of you guys this winter. I hadn't met any of you really, so it's just wonderful to get to know you, and I hope we see each other down the road.
Thanks so much for
Cool.
making it happen, Nick.
Yeah.
It's my
My
pleasure.
pleasure, you guys.
I look forward to
All right.
Saturday.
Thank you.
Take care.
Bye, everybody.
Bye.
Oh, maybe Nick did.
Bye. I just hit myself. But, okay. Okay. Flustered because I'm walking through the blood and the bones of a dismembered mega whale. That was Danny Coutts from downtown Vancouver, British Columbia. That was Mitch Mihalynuk from Victoria, British Columbia. That was Will Matthews from Calgary, Alberta. And that was Aaron Donaghy from West Lafayette, Indiana at Purdue University. Thanks to all of them. And we still have, roughly 700 that have hung in here for 2 hours. And I want to go to the laptop for a couple more minutes before we say goodbye. Come on now. I mean, I got stuff, so you knew this one was going to be a long one, probably. Let's go ahead and just finish up with a couple final thoughts. Am I still functional, by the way? Jerome, it's time for you to go to bed. Jerome's in Switzerland. It's after midnight there, and you got to get up for your 5 o'clock train or whatever. So thanks, Jerome, for sticking around. Okay. I don't know. I just feel like I want to go backwards just a little bit. I'm kind of reflective now, I guess. And we do have one more show, but we keep going back to 25 years ago and Daryl Cowan's paper of sending this whale to the north. And today's topic, here's Vancouver Island and Nanaimo Basin, and here's the closed ocean basin roughly. So this is just one of our models. But notice here's what Mitch was talking about today, his significant dextral fault within intermontane. Interquinelia. That's what Daryl called it back in 97. Yes, we started, but you knew we weren't going to stay with the Nanaimo Basin. I think you knew that. Maybe you didn't. I don't know. You just tuned in for a Nanaimo Revisited show, but we started with the Nanaimo and then went elsewhere. Here's the younger marine stuff, the submarine fans. Here's the older non-marine stuff. And pretty small basin compared to the scale that we're talking about. Yes, in the new paper from this Calgary group, we've got all these details, and all the old PCers show up in every one of these spots. Amazing. This is Mitch, and we are going to visit with Karin on Saturday, so we'll get another crack at some of this. But here's Mitch, at least down in California, trying to throw in a suture, as I think I understand it. Yeah, Mescalera ocean suture, running through the foothills of the Sierra, and running through the Klamath. Yes, Mitch, who you just spent time with today, is the co-author of The Fixed Archipelago, and yeah, we're back to the ribbon continent stuff. Okay. I wasn't brave enough, I guess, to get into this. I wasn't sure if we were going to get into it, but I think I'm stating it again that I'm not sure, but I think one of the main themes from Saturday, our last show Z, will be trying to visualize eastward versus westward subduction. Where is it happening and when's it happening? Here is Hildebrand talking about the ribbon continent and eastward subduction of an oceanic plate, creating the California Triad, creating a whole bunch of stuff that's familiar to us, but the only thing that's unfamiliar is this thing's out in the middle of the frickin' ocean. It's not in California at all. Yeah. Okay. Do I really want to do all this again? I don't think so. I wanted to do something else, though. You guys seem to like this. I'll show this. This is from the Chris Mattinson show. Subducting the leading edge of the North American continent underneath a major continent out in the water, whether we call that ribbon continent or insular or greater insular or whatever. I don't know. Yeah, and Stephen Johnston's going to be with us again on Saturday, and so maybe we'll get. Everybody seems to be interested in this. I'm talking about you, the viewers, now as I watch these replays. And remember, Stephen was this one saying, "I don't really think we need to take a mega whale and send it south, because it's all relative to how North America is moving." Okay. We don't need to go. That's plenty. That's plenty. A toast to you. Here's to you for watching an extra long show with a cavalcade of stars. Here's to Danny Coutts, who's still in the green room, from a high rise in Vancouver, BC. Here's to Will Matthews from his home in Calgary, Alberta. Here's to Mitch Mihalynuk from Victoria, BC. Here's to your health, your physical and your mental health, here in late February of 2023. And there will be more ribbon continent and fixed archipelago concepts on Saturday. Quick announcement and we're done. Please join us for the thrilling conclusion of Baja BC A to Z Saturday morning at 9 a.m. Pacific time with Basil Tikoff, Karin Siglock, and Stephen Johnston. You thought today was fancy? Well, we got Basil from Wisconsin, Karin from France, and Stephen from Edmonton, and me from Ellensburg, Washington, home of Cow Pie State University. And if you missed my major announcement at the beginning of today's episode, if you want to come visit Ellensburg, Washington, you're welcome anytime. This building, Discovery Hall, is open anytime. You're welcome to come in and wander around, and half the faculty now, so make yourself at home here. But in addition to that open invitation, I've decided recently to go back to doing live lectures with a big auditorium full of people. After 3+ years, it's finally safe to do that again. And so, if you've seen a few of my downtown lectures that were filmed for YouTube in 2019, 4 years ago, they were filmed in this auditorium. It's a beautifully restored old middle school auditorium. It's called Morgan Middle School, but it's a fancy auditorium. It seats a little more than 700 people. And I thought maybe some of you would be coming in from out of town for at least a couple of these. So I thought, well, I'm not going to do one. I used to do them every Wednesday. I do 4 lectures, but I would do them a week apart. I thought, well, we'll just have a little festival. And as I did at the beginning of this show, I'm looking for ideas on how to package all this exotic terrain material. I'm sure that I'm going to do 4 new lectures that are taking basically the greatest hits of not only this winter, but the previous 2 winters, the crazy Eocene and exotic terrains from my backyard. And I'm looking for a hook or some way to visually tie all that stuff together in 4-hour-long lectures with slides and chalkboards. And I don't think we'll be live streaming. I think I've hired a film crew from Yakima to come up and film it professionally, but I don't think we'll live stream. So they will be on YouTube, but not live. Okay, I think that's it. Thank you. I love you. And goodbye from Ellensburg, Washington, USA. We'll see you on Saturday morning February 18th, 9 a.m. Pacific. What do we have? All right. Goodbye from Ellensburg, Washington, USA.